I I didn't know such an invitation, but yeah. Now I'll talk about the essential techniques for tabular competition. First, I'd like to introduce myself. I'm Kazuki Onodera and Grandmaster since this April. And also, I'm data scientist at DMA, and I'm very glad to get second place. First, I joined FEG, that stands for Financial Engineering Group, not Feature Engineering Group. And then we got second place at KDD Cup. After that, yeah, this is a screenshot of KDD Cup. We are second place here. And then I joined Yahoo Japan. After that, I got first gold medal at Santa competition. You guys will know Santa competition is not machine learning competition, so I don't think it deserved. So, next competition is Instacart. This is also my first experience for Soul Gold. Yeah, 2 years ago I got second prize in this competition, and I really do like to get first prize, but I couldn't. After that, I got third prize at Santa competition as well. And then I joined the DNA. This is my current company. And the DNA has these systems. Our company supports doing Kaggle like this. So I think since joined this company, I got easily work on Kaggle. After that, I got second prize at home project. Yeah, this is also second prize. And then I got second prize at Santander. This is the latest one. And then now I'm Grandmaster now. So I like to describe how not to get first prize to everyone. The answer is team up with me. It's very simple and easy. Let's move on to the next topic. Yeah, this is main topic. How should we see the data? When I get the data, I'm always doing like these substatistics. For example, the left side is feature names, and then next to the data type, number of nodes, number of uniques, and so on. This statistics not so important but mandatory. Also, I'm always counting values. frequency and ratio. After that, I'm always plotting like this stuff. Not only statistics, but also distribution with target is worth to see. This is for continuous features, and next is for categorical features. Yeah, here's the deal. Also, Venn diagram is a little bit helpful. Okay, I will introduce my next techniques. Subset by ID. This example from Instacart. In this competition, we have to predict which grocery products our Instacart consumer will purchase again and when. Just imagine, for example, having milk ready to be added to your cart, right when you run out, or knowing that is time to stock up again on your favorite, something like ice cream. We have these data. User ID, order number, add to cart order, and product ID. This data is very interesting to me because we can easily know the name of items. In the competition, sometimes these values are anonymized, but this competition is not anonymized. But we can hardly understand the behavior of a user with this type of data. So I convert this data to like this. Regarding user 1, we can easily understand the user likes beef jerky, pistachios, and soda. And next user, this user pretty much always order cola, but at order number 8, the user did not order cola. Why not? Because this is my just assumption, probably because the user bought fridge pack cola instead of it. But that user also bought English muffin, so we don't know which is the replacement. In this way, we cannot find the truth because we cannot interview the user. Why didn't you buy the cola? But we can analyze this another user. Yeah, just focus on the item user buys after bought another items. This algorithm is very simple. Just focus on 1 to 0 and 0 to 1. For example, this user ordered organic milk at order number 1, but order number 2, this user did not order it. At the same time, this user ordered lightweight cat litter. So that item will be a replacement for the organic milk. Now I got this table. This table says like this: 45 users buy organic extra farm tofu after garbanzo beans no salt added, at least 1.9 times on averages, but co-occurrence is also 1.9 times on average. So I don't think this is not replacement. So, and then I just set the threshold for the co-occurrence, and the result is here. This table says 45 users buy organic garbanzo beans after garbanzo beans no salt added, at least 1.9 times on averages. Co-occurrence is 0.02 times on averages. So nobody wants to buy these items at the same times. I think this is a good example of replacement. On the other hand, 70 users buy garbanzo beans no salt added after organic garbanzo beans, at least 1.5 times on average. Also, co-occurrence is 0.01. So, compared to the before example, I think this is a good example for the replacement as well. And next example is here. 45 users buy organic skim milk after fat-free milk, at least 1.8 times on averages. Co-occurrence is 0.08 times on averages. Next example is here. 36 users buy Simply Sweet Campari tomatoes after Campari tomatoes, at least 1.5 times on averages. Surprisingly, co-occurrence is 0, so nobody wants to buy these items at the same time. Next example is a little bit interesting. This item is very popular in Instacart. So 9,133 users buy banana after bag of organic bananas, at least 1.3 times on average, but co-occurrence is 0.01 times on averages. So some users wanted to buy these items at the same time. I don't know why. Because the item is totally same. And this is KDB 2015. in this competition, we have the enrollment ID and the username and the course ID. We need to predict which user will not come on the MOOC. And we have these users' behaviors. As I showed before, the enrollment ID 1 and 4 has the same course ID. So I just wanted to compare to those. This user has same course ID, so the first three objects is totally same. But after that, this behavior is totally different. So I just need to know why. And this is a table for the calculated with group by object and order mean and standard deviation. As you can see, the index 0, order mean is 3.9 and the standard deviation is 1.2. So we can say there is an order to take a course, and then after that I plot those like this. So we can say the first object is mandatory because order mean almost 0 is also order standard deviation is almost 0. But after the some first course, I think we can take whatever we want. And I will introduce next techniques. Sorting. Sorting is very simple but very powerful techniques. This example is home project. We have application, training and test, and previous application. We need to predict which user will default. And the previous application is here. We have contract type, annuity, and so on. This data is very interesting because once we sort this data with annuity, we realize that there are some record looks like same applications. I thought this application is totally same because annuity and application and credit is totally same. Also, the goods price and process start time is totally same. But as I showed, the SQL ID is totally different. So I did these things. First, I subset these two users and then calculate the difference between date features. For example, date birth minus date registration and date registration minus date ID publish and days ID publish minus days employed. And then we can easily understand these users are same because the difference is totally same. When we get these information, what can we do by finding same users? We can do these things: log features, real features, and rate of changes, and aggregation, and etc. I've heard the same things happen on the latest competition. So I think these techniques is mandatory for all of us. Thank you for listening.
Thank you very much. Next is the question and answer process. If anyone have any questions, please raise your hand. Okay, there. 请给这边的先生送个话筒。
Hello, I also took the Santana competition this year, and so the unbalanced data make me a lot of trouble. So, do you have any advice to dealing with the unbalanced data?
Sorry, I hardly catch.
You know, the data of the Santana competition is so unbalanced. And so, do you have any advice to deal with unbalanced unbalanced class data?
Unbalanced. What? Sorry.
Unbalanced.
Unbalanced data.
Yes, data.
What kind of unbalanced?
You know, in the Santana competition, they have about 90% of class 1 and about 10% of class 2. So they are unbalanced data make me a lot of trouble.
So the question is, what if the data is unbalanced?
Yes.
Right?
Yeah.
It depends on the evaluation, I think, because if the evaluation is AUC, maybe we don't need to mind those kind of unbalanced. But binary overlaps or something like that, we need to know the data's centroid. I mean, maybe this takes a lot of time, so I will skip.
Okay, thank you.
Sorry.
Thank you. Any further question? Any further question? Okay, so if you can also contact with Onodera in after this speech. Okay, thank you very much. Thank you so much.
Thank you.